Okay, so quantum mechanics, as you know, it all started in 1900, and it is in fact a radical reformulation of laws of physics. When we say it's a radical reformulation of laws of physics, we mean to say that not only the kinematical structure of physics, but also the dynamical structure of physics was changed. And change and it was changed in a very fundamental manner. So we start with a basic description of kinematics and dynamics, and then we will swiftly change into what we have to do in your course here. So what is quantum mechanics? So quantum mechanics is the radical reformulation of laws of physics, and is divided into two parts. As in other case, हम यहाँ पे भी दो parts, एक है kinematical kinematics. What is kinematics? The the description of space of states, space of states and observables. And what is dynamics? The description of time evolution, description of time evolution of these states, time evolution of these states. So यहाँ पर दो बातें आ गई जो which requires some sort of description के states क्या से क्या मुराद है और observables से क्या मुराद है. So जो states हैं, these states of any system, or let's a system, let's say for example an atom or a molecule or a free particle, or maybe a photon. So the state of a system, maybe it is specified by giving the coordinates qi, and associated with coordinate there is a complex conjugate quantity, and which is known as momenta, yeah, which is known as the conjugate momenta, pi, for all the particles of the systems which are involved. And once this is done, all measurable quantities such as momenta, pi, the total energy, the Hamiltonian, the angular momentum, L, r cross p, those can be determined. And such measurable quantities, they are known as observables. So we have two things: the state of a system, which is specified by giving coordinates qi and conjugate momenta pi of all the particles of the system. And once you have done this, once you have specified the coordinate qi and pi, coordinate qi and momenta pi, then you go for the those measurable quantities. And what are those measurable quantities? These momenta, total energy, angular momentum. And when you have determined those measurable quantities, then they are basically known as the observables. So the the states of a system may be specified, may be specified by giving the coordinates qi and uh, momenta pi of all the particles of the system. And once this is done, once this is done, that is, once you have specified the coordinate and momenta, all measurable quantities such as momenta, pi, total energy, the Hamiltonian, जिसको total energy जिसको आप Hamiltonian कहते हैं, H, which is in fact sum over all the particles, which is pi square upon 2m plus v of qi. This is the total energy of the system. And angular momentum, and angular momentum, which is in fact written as L is equals to summation over I, Ri cross Pi, yeah, which is basically some vector relation, yeah, can be determined uh, yeah, and these such measurable quantities are known as observable. सो आपको दो बातें पता चल गई यहाँ से. States, the states of the system, how do you define or specify states of the system? They are specified by specifying the coordinates qi and momenta pi of all the particles involved in the system. Once you have done this, then you basically measure some quantities, and those measurable quantities, they are in fact known as the observables. अगर मैं क्लासिकली डिस्कस करें, सो किसी क्लासिकल सिस्टम में जो डायनेमिक वेरिएबल्स हैं क्यू आई एंड पी आई, वो कैसे इवॉल्व होते हैं? दे आर बेसिकली डिस्क्राइब्ड बाय some differential equations. So let's say we consider a classical system with dynamical variables qi and pi, where pi is the conjugate momenta. ये ख्याल रखिएगा, conjugate momenta. Yeah. And how they are related? This pi is related by this equation, the derivative of the Lagrangian with respect to qi. So this is basically the relationship between the conjugate momenta and the qi. और यहाँ पर जो I है, that goes from 1 to n, और n क्या चीज़ है? That is basically number of degrees of freedom. How many degrees of freedom are there? सो क्लासिकली ये तो हमें पता चल गया कि क्लासिकल सिस्टम के अंदर क्यू आई और पी आई का क्या मतलब है. सो क्यू आई and pi is the conjugate momenta, and how these two are related, they are related by this relationship. So जो हम इनफैक्ट postulates लिखते हैं क्वांटम मैकेनिक्स के अंदर, उनका क्लासिकल वर्जन जो है वो इनफैक्ट कुछ इस तरह से. सो इन in classical mechanics, जो state of the system, the state of a system is specified by a point in phase space. Yeah. वो phase space का मतलब क्या है? That is, this point is represented by qi and pi. So the point is specified by pi, which in fact depends upon time. So which depends on time. Yeah? So this you think this can be written as the first postulate. Number two, so यहाँ पर आपने स्टेट डिफाइन कर दी। क्लासिकल सिस्टम की बात कर रहे हैं। ऑब्जर्वेबल का मतलब क्या है? अ डायनामिकल वेरिएबल। डायनामिकल वेरिएबल का मतलब ऐसा वेरिएबल विच इज अ फंक्शन ऑफ टाइम। सो लेट्स से अ डायनामिकल वेरिएबल ए, सम डायनामिकल वेरिएबल ए, और ऑब्जर्वेबल, उसको ऑब्जर्वेबल भी कहेंगे। और ऑब्जर्वेबल is a function of this qi and pi, is a function of qi and pi. For example, ये फंक्शन क्या हो जाएगा? A is in fact a function of qi and pi. या ये सेकेंड पॉस्टुलेट हो गया क्लासिकल मैकेनिक्स का। थर्ड पॉस्टुलेट क्या होगा? इफ द सिस्टम if the system is in a state A, sorry, in a state, sorry, in a state qi pi, then the result of measurement, result of measurement of an observable a वो क्या हो जाएगा? is a of qi pi. This is the result of an observable. Yeah. This is the result of the measurement. Yeah. So you measure the some observable for a system which is in a state QIPI, and the result of that measurement is in fact this observable A of QI. इन क्वांटम मैकेनिक्स में क्या होता है वो हमने क्लासिकल मैकेनिक्स की बात की। इन क्वांटम मैकेनिक्स जो स्टेट है, नंबर वन, द स्टेट इज अ रे, इज इज अ रे और अ स्टेट रादर, उसको स्टेट कहें या रे कहें, ठीक, इन अ हिल्बर्ट स्पेस। सो उधर हमने क्या बात की थी? फेज स्पेस की। इधर इन हिल्बर्ट स्पेस। या दो, दूसरी बात, जो ऑब्जर्वेबल जो है वो सम हर्मिशन ऑपरेटर, दैट इज एन ऑब्जर्वेबल इज अ हर्मिशन ऑपरेटर, ऑपरेटर ऑन द हिल्बर्ट स्पेस, ऑन द हिल्बर्ट स्पेस। मतलब qi would change to qi cap as an operator, pi would change to pi operator. Yeah, so the जो in fact हमारा coordinates हैं, they would change to operators, and therefore the observable जो है a, जो हम classical mechanics में a qi pi लिखते थे, that would change to a as an operator, which is equals to a as a function of qi operator and pi operator. Yeah, so this is notation वो इस्तेमाल करें, ठीक है ना? So we have these qi and pi. They if we change them in into quantum mechanics, in quantum mechanics as operators, then they must obey some fundamental relationship that is known as fundamental commutation relationship. So the operators qi and pi in quantum mechanics obey the fundamental commutation relation. Uh, and what is that relation? That would be Qi Pj, and this is equals to iota h bar Kronecker delta function I j. Yeah. And इस प्रोसेस को क्या कहा जाता है? दिस प्रोसेस ऑफ promotion of observables to operators is known as quantization. तो एक बात का ख्याल रखेगा, ये बहुत इम्पोर्टेंट है, और इट हैज़ लॉन्ग लास्टिंग इनफैक्ट एप्लीकेशन इस स्टेटमेंट की जो ये हमने लिखा है, not just in quantum mechanics but also in quantum field theory, in the quantization of electromagnetic field. ये बुनियादी तौर पर टू लाइनर इनफैक्ट प्रोसेस लिखा गया है कि हाउ टू क्वांटाइज. सो अगर हम कोऑर्डिनेट्स और कॉन्जुगेट मोमेंटा को ऑपरेटर्स में कन्वर्ट कर रहे हैं, देन जो इम्पोर्टेंट पार्ट है जिसको कहते हैं नेसेसरी एंड सफिशिएंट कंडीशन, वो क्या है कि दे मस्ट ओबे, दीज ऑपरेटर्स मस्ट ओबे अ फंडामेंटल कम्यूटेशन रिलेशन, एंड इफ दे ओबे अ फंडामेंटल कम्यूटेशन रिलेशन, ओनली देन द प्रोसेस ऑफ क्वांटाइजेशन इज कंप्लीट. uh, if we do not specify the fundamental commutation relation for the operator, then the process of quantization is not complete. Yeah. So it means that in order to complete the process of quantization, you need to specify the fundamental commutation relation. And this specification of fundamental commutation relation, it starts from the description of quantum mechanics as as a new discipline in physics, all the way to second quantization and then to quantum field theory. Yeah. So this is very important sort of a statement है. And इसका क्लासिकल एनालॉग जो है वो पॉइजन्स ब्रैकेट होगी, जो कि हम क्लासिकल मैकेनिक्स में करते हैं. सो ये जो प्रोसेस है, दिस प्रोसेस हैज एन एनालॉग. दिस प्रोसेस obeys the commutation relation in classical mechanics, जिनको पॉइजन ब्रैकेट कहते हैं. दैट इज ये कर्ली ब्रैकेट ए कॉमा बी बराबर है किसके? सी के. सो यहाँ पर ये चीज़ जो है, यानी ए ऑपरेटर कॉमा बी ऑपरेटर, ये ऑपरेटर कॉमा बी ऑपरेटर इज इक्वल्स टू आयोटा एच बार सी ऑपरेटर प्लस हायर ऑर्डर टर्म्स h bar square terms and higher order terms. So this is basically some commutation relation in classical in quantum mechanics. Yeah. And so classical mechanics के अंदर ये जो ये वाली चीज़ है वो कैसे होती है? सो क्लासिकल ऑब्जर्वेबल्स अगर आपको थोड़ा सा याद करना हो, तो क्लासिकल ऑब्जर्वेबल्स जो हैं वो कैसे रिलेट करते हैं एक दूसरे के साथ. सो फर्स्ट करें, वी हैव क्लासिकल ऑब्जर्वेबल्स ए, क्यू आई एंड पी आई, and there is another observable B, which is a function of Qi and Pi. Then they are related by the Poisson bracket. And these Poisson bracket कैसे लिखी जाती थी? So they are written as A comma B, and this is equals to summation over I, partial derivative of A with respect to Qi, partial derivative of B with respect to Pi, minus partial derivative of A with respect to Pi, सुपरस्क्रिप्ट में. and partial derivative of B with respect to Qi. So this is basically the Poisson bracket, and in fact, we could write for Qi and Pj in classical mechanics as delta function I, Kronecker delta function there. And so you could think about these two relation. अगर मैं इन दोनों relations, ये relationship और ये relationship हम देखें, तो इन दोनों के दरमियान अगर कंपेयर करें इन दो relationships को, so relating Qi Pj is equals to iota h bar delta function ij with uh, Qi Pj is equals to delta function ij would give क्या चीज देगी? This would give that this quantity, that is classical Poisson bracket, is related to 1 over iota h bar quantum commutation relation. Yeah. So the relationship between this and this is in fact nothing but quantization. Yeah. So this is quantization. So you go from classical mechanics. So you go from classical mechanics to quantum mechanics by this factor, by the introduction of iota h bar. This is basically how you change from classical mechanics to quantum mechanics. Yeah? नो, जो तीसरा पार्ट है, तीसरा आपका जो जिसको आप आइगन वैल्यूज कहते हैं, सो वी कुड थिंक अबाउट थर्ड वन। इससे पहले हम तीसरा जो आपने इनफैक्ट क्लासिकल मैकेनिक्स में तीसरा पॉइंट हमने डिस्कस किया था, उसमें हमने कहा था सिस्टम इज इन स्टेट क्यू आई पी आई, एंड जो रिजल्ट ऑफ मेजरमेंट है ऑफ दिस क्यू क्यू आई इज एन ऑब्जर्वेबल। यहाँ पर जो रिजल्ट ऑफ मेजरमेंट है वुड गिव यू सम आइगन वैल्यू। या सो वी वुड से 3 if psi is some state, is an eigenstate of A, yeah, some observable with eigenvalue, with eigen with eigenvalue small a, then the outcome of a measurement of A is A, which is an eigenvalue। ठीक है ना? सो दी इसका मतलब है दिस इज बेसिकली, अच्छा, इसको हम दो हिस्सों में तकसीम करते हैं। इसको अगर मैं 3 कह दूं तो वी हैव अनदर, in fact, the third postulate in quantum mechanics, in fact, two more versions. So what is the probability that the measurement of for an outcome would be a small a? इसका मकसद ये हो गया कि हम वो measurement वो probability भी define करें, and what is that probability? So in general the outcome of an observable of A is one of the eigenvalues, one of the eigenvalues, values of A. And what is that probability that the eigenvalue would be A? So the probability that eigenvalue A would would be an outcome that would be proportional to the square of the mod of the overlap of the wave function. Yeah. So this is what is this? This is the eigenstate A with eigenvalue with eigenvalue A. Yeah. एंड तीसरा इसका पार्ट हो सकता है द स्टेट आफ्टर मेजरमेंट, वो डिफरेंट हो जाएगी, इसको कोलैप्स ऑफ द वेव फंक्शन कहते हैं, द स्टेट आफ्टर एन ऑब्जर्वेबल, आफ्टर एन ऑब्जर्वेबल of after an observation rather, after an observation of eigenvalue A is A. Yeah, so the system goes from some state to the state A जिसकी eigenvalue क्या है, small a है. Yeah, and this is basically the collapse of the wave function. So one could say that this is known as the collapse of the wave function. So the system is no longer in the state psi, but it is now in the state A, yeah, or the cat A wave function. This is known as the collapse of the wave function. So this is, in fact, a general description about what we think about kinematics and dynamics. तो इसी चीज को अगर मैं सम अप करूं तो स्टेट्स क्या है, स्टेट्स आर रिप्रेजेंटेड बाय कैट्स इन हिल्बर्ट स्पेस. And what are observables? These observables are represented by some special type of linear operators known as the Hermitian operators. And the outcome of observations of an observable is one of the eigenvalue of these observable, and the probability of that observation is defined by this equation P of A is proportional to the absolute value squared. Yeah. And so अगर मैं सम अप करूं, समरी लिखें, समरी सम अप किया जाए इसकी, तो हम इसको सम इन टर्म्स ऑफ अ शॉर्ट डिस्क्रिप्शन क्या लिखा जा सकता है, वी कैन से द स्टेट्स आर represented by cats of or cats in Hilbert space. Yeah, in Hilbert space, and observables are represented by some special type of linear operators known as Hermitian operators, and the outcomes of observation of an observable is one of the eigenvalue value of this observable, and the probability of observation कि वही observable आएगा, या of observing a particular eigenvalue is proportional to the absolute to the absolute value squared of the overlap between the the state that represents the physical state of the system and the corresponding eigenvector of this Hermitian observable. And one of the properties of QM, quantum mechanics, is the uncertainty principle. Yeah. So this is the complete description जो in fact हम लोअर क्लासेस में पढ़ते हैं कि अगर मैं ये तीनों पॉस्टुलेट बुनियादी तौर पर अगर आपको कभी डिस्क बताना हो तो ये स्टेटमेंट समरी है उन तीन पॉस्टुलेट की कि states are represented by cats in Hilbert space. Observables are represented by special type of linear operators known as Hermitian operators, and the outcome of observation of an observable is one of the eigenvalue of this observable. Yeah, यहाँ तक बात खत्म हो गई एंड देन वी टॉक अबाउट बिकॉज the observable could be energy. अब energy of the lowest energy state, energy of the first excited state, or energy of the second excited state, energy of the third excited state, and so on. So energy is the observable, but in which what is the outcome of measurement of an observable, let's say energy observable, that would be depend upon the probability. So the probability of observation of observing a particular eigenvalue, that would be proportional to the absolute value squared of the overlap between the state, that is psi, of the system, and the corresponding eigenvector of the Hermitian observable, यानी small a. Yeah. So eigenvector small a. So यहाँ पर हम जो बात कर रहे हैं फिजिकल स्टेट की, वो बात हो रही है, इधर बात हो रही है साई की, और इधर बात हो रही है आइगन वेक्टर ए की. Yeah. So we are talking, and the overlap is between psi and A. And this overlap is basically not an absolute value. It has some uncertainty involved in it. And that's why we write commutation relationship. So the uncertainty is of the order of iota h bar s as per the commutation relationship. So this is in fact